Okay, so welcome to another episode of The Little Classroom That Could. In today's episode, we're going to be looking at Chapter 8C, from the strategies to minimise interest. In this particular instance, we're going to start off with 8C.1, making larger repayment per period. So if we look back on our loans that we've kind of covered in 8A and 8B, and let's look at in particular mortgages, over a long period of time, you can see that we're paying quite a substantial amount in terms of interest. In some instances, for higher interest rates, we're actually paying more in interest than the principal value of the loan to start with. Okay, so remember, that's money that the bank is just going to be making. So as a mortgagee or the person who's got the loan out in their name, remember, we want to reduce the amount of interest because that's money that we could be doing something else with. Okay, so there's different strategies that we can employ to do this. One of which is making larger payments per period. So over the term of the loan, we can look at paying an extra amount of money. So let's take a look at an example and we'll do question 2 as an example. So let's start off with a $195,000 home loan is negotiated over 30 years at 7.2% per annum interest compounded quarterly. Let's start with highlighting some important information. So we're asked to compound quarterly, 7.2% per annum interest. It's over 30 years, and the principal amount or the present value is $195,000. Okay, so let's plug this into our trusty friend TVM calculator. So we're now compounding, and payment periods per year will be quarterly, so that will be 4. Future value of the loan will be 0. The payment, once again, is what we're trying to solve. The present value is $195,000, and the interest rate is 7.2%. And the number of terms is 30 years times by 4 quarters. 30 times by 4 is 120. And if we solve for our payment value, we should end up with minus $3,977.62. So the minimum amount we have to pay is $3,977.62. Next part of the question asks us, if an extra $200 per quarter is added to the repayment, how long will it take to repay the loan? So in this instance, we're not going to be solving for payment. So how long is it going to take to repay the loan? We're actually going to solve for n. But remember, we have to pay an extra $200 per quarter. So this will take this amount to 4,100. So let's just plug these values into TVM solver. 0.62, plug it up, and alpha solve. So this is going to give us 102.79. So it's fair enough that the calculator is going to give us that answer of 102.79 quarters, but we can't resolve the answer in terms of quarters. It has to be, in parts of quarters, it has to be a whole quarter. So in this instance, it will actually be 103 quarters, or if you wanted to put that in years, you could multiply 103 by, so divide that by 4, and you'll end up with 25 years and 3 quarters and 9 months if you wanted to transfer it. I personally would just leave it in terms of quarters and be done with it, but if you asked to convert to years and months, here we go. Last question we're asked is part C is, how much interest would be saved by making higher repayments? Okay, so the way we'd go about to solve this is interest saved equals the total amount of periods that we started with, so that's 120 times by whatever we started paying, so 3977.62. So that's the total amount that we'd be paying. on the first instance, minus 103 times by 4177.62 close bracket. Now if we stick that in our, if we quit our TVM calculator, go to normal mode, open bracket, 120 times by 3977.62, close bracket minus open bracket, 103 times by 4177.62, close bracket, enter. We end up with the answer of $47,019.54. So as you can see, by paying an extra $200 a quarter over the period of the loan, over the term of the loan, we're going to save ourselves best part of 50 grand. So remember, you might not be able to, just thinking in a bigger picture, you might not be able to do this at the start, but you might be able to do that later on, because remember, this is all calculated in current present dollars. If you recall from chapter 7 in the work, we talked about the decreasing value of money. So your buying power is decreased. So this what we start with of just shy of $4,000 a quarter, that might be a lot in today's money for you as an individual. But in 10 or 15 years' time, because your wage would have increased, living costs would also increase, but that repayment value is going to be the same. It'll be just shy of $4,000 in 10 or 15 years' time. So that amount of money out of your purse string, out of your available money to spend, would be a smaller proportion. So you could actually, as your time goes forward, you could actually afford to pay a little bit more on top of that to pay your mortgage off sooner. So that's a tactic that some property investors do use. Thank you. Okay, so now we're going to look at 8C.2, making more frequent repayments. So now we're going to look at instead, if we made more payments per year, what effect does that have? So because there aren't very many questions in this chapter, I've made one up. So we've got question X. So a mortgage is taken out for $200,000 at 7.4% per annum, compounded quarterly. Over 30 years. So in this question, we have a mortgage that is taken out for $200,000 at 7.4% per annum, compounded quarterly, over 30 years. Let's find the minimum monthly repayment. So let's populate the values that we're going to need to find. So we're going to find the payment to start with. Future value will be 0. Compounding periods per year and payments per year will actually be 4. Payment, so obviously we need to find this. The present value of the loan is $200,000 and the interest rate is 7.4%. And the number of periods is 4 times by 30, which is 120. Alright. So if we stick all these values into a TVM calculator, we end up with a payment value of $4,161.21. Remember, we need to pay this money out, so it's an outgoing sum, so it's negative from the borrower's perspective. Okay, so $4,161.21. Let's whack a dollar sign out in front. If the repayments of 1/3 the original are made, but instead weekly, what is the new term of the loan? Okay, so before we move on, let's just remember the fact that the original term of the loan would have been 30 times by 52, which is 1,560 weeks. So now we're going to use this set of values to solve for the number of terms. So we're using interest rate of 7.4, original present value. The payment, all I've done for this field is divided this value by 13, and the final value will still be 0, and I've changed these two fields to be 52 because we're going to have 52 weeks per year. So if we go into TVM calculator, so a TVM solver, and we solve for this value, we end up with $1,546.46 894. Da, 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 da. So remember, we can't have a partial week, so this has to be, what is the new term alone? I would leave that as 1,547 weeks. Okay, there we go. So yeah, as you can see, we've managed to reduce the term alone by 13 weeks. Thereabouts. So now we have to determine how much interest would be saved. So the interest saved would be the total payments in the first instance, which would be, what was it, 4,161.21 times by 120 minus, this instance we have 320.09 multiplied by 1547. Now if we go back into our calculator, our standard mode, and plug this in, we go with open bracket 4161.21 times by 120, close bracket minus open bracket 320.09 times by 1547, close bracket, enter. We can see here we've saved 4,165.97. As we mentioned earlier, we've saved about 13 weeks, which is a quarter of a year. So this puts us in about the same value as we did for when we were paying our total or paying per quarter, which makes sense. All right. Now, just a trap for young players, when I'm entering these values in for PMT, we have, for this negative value, you have to use the negative key on your calculator, not the subtraction key, because otherwise it gets confused because subtraction is an operation and negative is, well, effectively a value. So the calculator will get confused between the two. Okay, so now let's turn our attention to 8C.3, which is reducing the term of the loan. So what we're talking about here is, instead of having a really long term of the loan, let's reduce it and make it shorter and see what happens, in hoping to minimise the type of total interest we pay. So here's our example for question 2. Justine is taking out a $310,000 loan at 5.4% interest, compounded monthly. So, the question we're asked is, find the minimum monthly repayments if the loan is taken out over 30 years and then at 25 years. So let's go and set up our values for TVM calculator. So we know we're compounding monthly, so this here will be 12 and 12, final value will be 0. The payment is what we're solving. The present value is $310,000. The interest rate, we're told, is 5.4%. Our number of terms, so 30 years at 12, 3 turns, 360, that's 360 periods. So, we plug that into our calculator. We'll start with 360, 5.4, 310, 123, 0 and 12, future value, and we solve for our payment value. We end up with minus $1,740.75. So here let's plug this answer in over here, $1,740.75. So now we're told for 25 years, so that would be 25 times by 12, which is 25, 50, which will be 300 periods, which makes sense because 5 times by 12 is 60, so it should be 60 less. So let's go and set that number up. Leaving everything else the same. Just changing the number of years once again, so a number of periods, solving for the payment value, we end up with minus $1,885.20. So let's write this in. $1,885.20. So how much interest would Justine save by taking out the loan over 25 years instead of 30? So, remember, I saved is equal to taking out the loan over 25, so it would be 30 times by $1,740.75 minus, so it's not 30, it would be 360 minus 300 times by 1885.20. Here we go. So if we quit out of TVM mode, stick this in, say open bracket 360 times by 174.0.75, close bracket minus open bracket 300 times by 188.5.2, close bracket, enter. So this will equal $61,110. So give a reason why part C. So for part C, we're asked to give a reason why Justine may still decide to take out the loan over 30 years. Well, quite simply, she might not be able to afford the extra, what's that look like? The additional $155, give or take. She might not be able to afford the additional $155 a month. Might not have it in her salary, might not be earning that much. So that's one reason why she might not be able to do that. Okay, thank you.